And hello to all. Thank you for tuning into this AWS Online Tech Talk. As mentioned, my name is Ian Perez-Ponce with the Platform Business Development Team here at Amazon Web Services. And today I'm pleased to be leading this deep dive session on large-scale data migration and edge compute use cases using the AWS Snow Family of service. So with that, let's go ahead and begin. So to help frame the conversation, I'll start by asking what might seem a bit like a loaded question, and that's what's driving storage relevance in the first place? And the simple answer is data, and yes, we all know data is generated by various application workloads and users, and where the apps go, the data must follow. But I'd like to call to your attention some of the more shape-shifting workload trends that present us with different perspectives in how we think about scaling to accommodate data collection, transfer, and storage. From AI initiatives, where there's usually an acute focus on pulling in vast amounts of distributed data, to train models for machine learning, deep learning, to use speech, such as natural language processing as an input to both analytical workflows, we're starting to observe a compound effect in data acquisition and transfer needs. In the realm of the Internet of Things, we see certainly an addition of multiple endpoints that are generating data from megabytes to gigabytes and having and adding to the actual data pool that's being used to harvest actionable insights for service operators or providers. And then in the realm of information assets and data trust frameworks, we have organizations that are actually starting to treat information as articles or artifacts of monetary value and looking to exchange those on a global basis. And so you start to see, whether from conventional workloads, back office type applications, to some of these bleeding edge workloads, the need for actual unlimited storage scale and being able to move data around becomes quite critical. At AWS, we see cloud storage as core and have a rather strong sense of conviction that data truly matters at any scale. Whether you're building cloud-native applications in AWS or migrating an existing on-prem application environment tomorrow, we aim to provide breadth of choice, including options for migration and data movement services to get the job done. Ultimately, we realize the ability to scale and the timeliness of scaling matters when trying to yield more meaningful insights from your data, especially as we see the scope and reach of big data and data lake deployments extend to all parts of the business. And only by yielding those insights can more transformative changes really come about in your organization, which is where harnessing the power of AI, machine learning, deep learning, and IoT technologies comes heavily into play. At AWS, we spent over 12 years listening to customer feedback on storage and data-centric services, leading the present-day portfolio. To date, 3 functional areas have remained at the center of innovation over the years. 1, core platforms, which you see in the middle, that offer the right application I/O interfaces, performance, and cost dimensions across a mix of object, block, and file classes. 2, security and management capabilities or tools to ensure the integrity of customer data is protected while providing deep integration with other services that can consume that data on an as-needed basis. And then on the left, data movement. We understand that applications without access to data are not very useful, and so we provide various services and products to help bridge that gap. Since the primary focus of today's session is on data transfer, let's briefly double-click on the different services AWS provides to help ease the burden of data movement. You'll notice we break these down by functional category. First, network-oriented services, which includes Direct Connect for dedicated 1 gig or 10 gig Ethernet connectivity to an AWS region of your choice. 2, S3 transfer acceleration for optimization of uploads and downloads to or from S3 buckets from remote users that might be subject to low bandwidth and or high latency links. 3 is EFS file sync, which is targeted specifically at simplifying NAS migrations for, I would say, NFS compatible storage that's sitting on premises and bringing that into Amazon Elastic File Storage. And then we have Kinesis Firehose, which enables simple and automated streaming and batching of data into S3. In the physical category that relies on actual road infrastructure, and this is where we'll spend most of today's session on, is the AWS Snow Family, which consists of purpose-built appliances that we provide for shuttling data without any dependency on network infrastructure. And then lastly, we have our hybrid category, which includes a myriad of partner solutions across the APN ecosystem, as well as the AWS Storage Gateway, which supports a number of different use cases that enables a mix of hybrid cloud storage solutions for things like backup and disaster recovery, to capacity bursting, tiering, and general purpose migrations. We'll be covering Storage Gateway in more depth in a subsequent Tech Talk, so we ask that you certainly stay tuned for that. So one of the things to bear in mind is that we have plenty of resources to get to help you migrate. Whether you're looking at AWS Migration Hub on the top left, or some of the migration services that include Application Discovery Service to AWS Server Migration Service, and then some of the data transfer services that we actually covered on the previous slide. And then on the bottom half, we have various partner solutions or partner tools that basically apply to different stages of the migration process. These are all AWS vetted partner solutions that customers have found useful throughout the different stages of migration, and are offered through AWS Marketplace at pre-negotiated discounts. So we encourage you to take a look on Marketplace for additional information on those solutions. One of the things that we did not call out is, from an application migration pattern perspective, you'll find that there's various decision triggers that come into the fold as you're looking to move workloads into the cloud. And quite often you'll find that the actual data migration effort component is missing or treated as an afterthought. And so whether you're rehosting, replatforming, repurchasing, re-architecting, or retiring your applications, we encourage you to invest the due diligence up front to understand the trajectory of your data and how best to migrate it. And so with that, I'll bring up the 5 fundamental steps to effective data and storage migrations. The first is really knowing what cloud storage service or tier you plan to migrate to, and certainly from, which seems pretty obvious. The second is around data discovery at the source, which is understanding the dimensions and structure of the data, the application data that you plan to migrate. Third is being able to validate that data before and after migration so that you can ensure integrity is intact. Fourth is understanding the particulars of the data transfer method that you have at your disposal before selecting one, or perhaps more than one, bearing in mind not all data transfer methods are created equal. And then fifth is really a point around marshaling that data as you start your actual migration exercise. And so being able to ensure that you have accountability of the data as it moves from point A to point B, and making sure that transfer efficiency is at its best. So let's pivot a bit into the actual use cases that we mentioned: large-scale offline data transfer and edge processing with the AWS Snow Family. And we'll start by asking the question, what is Snowball and why did we build it? And so over the years, we've learned that through customer experiences, moving large volumes of data over the internet can be costly in terms of time and expense. So creating a purpose-built appliance such as Snowball without customers having to actually purchase hardware really eliminates or reduces significantly that friction with large-scale data ingest. Secondly, in many cases where the cloud is not always accessible or practical, especially for those extreme remote locations where network connectivity is limited or altogether intermittent, ruggedized devices such as Snowball Edge can provide durable storage as well as compute capabilities that can be deployed at a customer's premises without the need to communicate back to AWS. And then lastly, for customers that have actually relied on shipping conventional hard drives for importing data into the cloud, we found that shipping these in the hundreds or thousands is highly error-prone. And so Snowball and Snowball Edge, we've introduced automated logistics to make sure that whether shipping one or many devices in parallel, is as frictionless as possible. The Snow Family consists of 3 platforms that you see listed here. Snowball, which comes in 50 or 80 terabyte storage densities and provides a fully ruggedized enclosure aimed at mainly data migration use cases. Snowball Edge in the middle, which has 100 terabytes of storage capacity and includes additional compute services that can aid in remote data processing as well as data capture for migration. And then Snowmobile, which is effectively a large snowball on wheels and is aimed at wholesale migration efforts such as data center shutdowns or massive archival projects where exabyte scale storage is an absolute necessity. Specifications-wise, we have an at-a-glance view here into what the different speeds and feeds between the different Snow platforms are. From a pricing perspective, the fee structure for Snow Family is pretty straightforward. Snowball and Snowball Edge have a flat rate job fee per device, as well as a daily usage fee, which starts to accrue after the 10th day of the device being deployed at your site. Snowmobile, on the other hand, is prorated based on the total amount of provision capacity, which is based on a 30-day billing period. Customers often ask which Snow platform is the right choice for migration needs. And ultimately, there are several factors to consider, but if we're only looking at storage volume as a key criteria, then we tend to reserve Snowmobile jobs for migrations in excess of 10 petabytes, while Snowball or Snowball Edge can be used in parallel to accommodate sub-10 petabyte migrations. If you're at a point now where you're planning a significant data migration effort to AWS, please reach out to us via your account teams. We'll be happy to work with you on the platform selection process that's the best fit. Using the Snowball service for data import is a relatively straightforward process that consists of 4 steps. Step 1, creating a job in the Snowball management console where you select the actual device type you wish to use. Once that device ships to you, you connect it in your local environment, which is step 2. The third step really stems around actually initiating the data transfer from wherever your local data sits, whether it's a SAN or NAS environment. And then the fourth step entails returning the device back to AWS so that we can start that import process into your S3 account. Start to finish for an import job in a best case scenario can take roughly 10 days, bearing in mind that this can change depending on a number of different environmental variables. So before kicking off a live migration, we always advocate for testing up front to make sure customers are comfortable with the entire process. Coming back to the question of which Snow platform to use, I'll highlight some other key features besides storage density that may come into play. For Snowball devices specifically, we have a few different methods for transferring data to the device, which include an S3 compatible adapter, as well as the Snowball command line interface, which includes key features such as automated batching for small files to increase throughput performance. Other notable features include chain of custody tracking to always know where your particular Snowball device is physically located, as well as compliance certifications, which may come into scope depending on the data you may be importing. Switching to Snowball Edge, you'll notice a few different features, starting with data transfer methods that include a native S3 endpoint without a dependency on an SDK, built into the appliance, as well as the option to use NFS over a file interface. On the compute side, we also support clustering of devices, which can aggregate capacity across services such as AWS Greengrass and EC2 to support horizontal scaling in your environment. Irrespective of the platform type, we've seen a mix of customers rely on the Snow family for various data import as well as data export use cases. You can see several of the customer logos referenced on the left, which include a pretty diverse mix of industries and verticals. And then on the partner side on the right, we have a growing list of ISVs that have integrated with the Snow family to support a range of use cases such as backup, DR, and migration seeding. Again, these represent AWS vetted partner solutions that you can find more information on in the AWS marketplace. So let's briefly talk about what customers are using the Snow family for. The use cases are manifold, but I'll call out the more popular themes we tend to see, such as wholesale data center migrations, where customers are exiting the data center management business altogether. 2 is backup seeding for disaster recovery. For database migrations, we'll often see Snowball used with database migration service and our schema conversion tool. And then for NAS appliance migrations or archival projects, we see traditional NFS SIFS data making its way into S3, EBS, or EFS, or a mix of the 3. And then we also have data lake creations for big data style projects where seeding a data lake environment in S3, for instance, is quite critical. And last is active archive, where customers are trying to get off tape or other forms of cold or nearline storage for better efficiency of archival use cases. So there's a 7th use case that we didn't cover on the previous slide, and that really has to do with edge computing. And this is really stemming from scenarios where migrating data over distance isn't really the most effective option. So what is edge computing and where do we see it taking shape? The common thread here, regardless of industry, is really looking at specialized application environments that exist well beyond the boundaries of a conventional data center and involved a couple key characteristics. One, decentralized data processing and decentralized generation of data, where data volumes are quite significant, often approaching petabyte scale on a monthly or quarterly basis. And third, network connectivity is usually inaccessible or intermittent. So industry-wise, this isn't an exhaustive list, but we're really starting to see strong interest across a diverse base ranging from academic research to transportation, with new ones surfacing on a regular basis. For these various industry use cases where edge compute is a key enabler, we come back to Snowball Edge and some of the key features we mentioned that go beyond pure data migration enablement. With Lambda functions enabled by AWS Greengrass or by using EC2 instances, data that's generated at the edge can now be processed using the Snowball Edge device, with or without the need to import that data at the customer's discretion. Workflow-wise, you'll still be creating jobs via the Snowball Management Console with the addition of specifying specific Lambda functions and or EC2 AMI images that you want to have available local to the Snowball Edge, wherever it may be deployed. Again, the idea here is that connectivity back to AWS is not required to sustain local data processing or affiliated workloads running on Snowball Edge. Taking a closer look at the EC2 functionality that we introduced for Snowball Edge, SBE1 instances are unique to the platform, and you see the various instance types and sizes there on the right. You can find the actual AMIs that we support listed in our documentation, as well as posted on the AWS Marketplace. Specs-wise, each Snowball Edge offers up to 24 vCPUs and 32 gigs of memory for use by your instances and up to 1 terabyte of disk capacity per boot volume. Lastly, we've introduced a couple new pricing terms and options, given that the use cases for edge compute often require longer deployment periods, and so you'll notice that 1 and 3 year pricing referenced on the bottom. Let's talk about Snowball Edge clustering and how to overcome scaling issues when one Snowball Edge isn't enough to power your edge compute requirements based on the specifications we covered. With the clustering feature for Snowball Edge, we can scale from anywhere from 5 to 10 nodes today and support both compute and storage aggregation across the cluster. And so you see the corresponding CPU and memory as well as storage scale there on the right. It's worth noting that as you grow a cluster in scale or size, the durability of S3 storage also increases, which can provide a more resilient object data store depending on your unique application requirements. Lastly, cluster maintenance is pretty simple to manage with the ability to swap out nodes as field replaceable units. So think of this as kind of a propane tank model where you send us one back and we provide a replacement for you on an as-needed basis. From a pricing perspective, for EC2 instances on Snowball Edge, we've made a few changes, which you can find on the main landing page for the service. I already called out the 1 and 3 year discounted terms. The main call out here is just to show the on-demand pricing that includes job and daily fees, which are $500 and $50 respectively for North America, and you can see some of the other regional pricing listed here. So coming back to some of the industry use cases we mentioned before, let's take a brief look at Philips Healthcare. As part of their Health Suite offering, Philips manages a pretty complex health ecosystem of digital tools backed by AWS to support over 14,000 global deployments, often in locations where network access constraints are prevalent and can introduce unnecessary risk to healthcare operations that rely on the Health Suite platform. So using Snowball Edge with EC2 and Lambda, Philips is now looking at extending its use of core AWS services at the edge for these 14,000 deployments to support medical imaging and optical scanning solutions that play a key role for healthcare facilities. And so the impact here is being able to sustain local operations without any real critical dependency for network access or round trip times to the cloud, which can be cost prohibitive. Another example in the energy sector is GE Oil and Gas, which uses pipeline inspection gauges, otherwise known as PIGs, to survey thousands of miles of complex pipeline infrastructure, which involve the collection and processing of instrument data. Where Snowball was previously used or leveraged to deal with the initial data acquisition and migration requirements, Snowball Edge with EC2 closes the gap in processing that valuable instrument data to derive meaningful insights that can reduce mean time to repair or replacement without having to incur lengthy round trip times or impact operational efficiency in the field. And then one last example here is in the academic research space, where organizations like Oregon State University and the Hatfield Marine Science Center there have been in the business of managing ship fleets for various ocean ecosystem research purposes. That research routinely results in the collection of raw data for processing, analysis, and ultimately archival, which previously required significant investment in data shuttling technologies such as conventional disk media and local compute infrastructure, which was capital intensive. Using Snowball Edge, initially with Greengrass and Lambda, OSU has been able to significantly compress their data collection and processing timelines by harnessing local compute capabilities while deployed and only shipping valuable or pre-processed data back to the cloud, which can then be used as part of a larger aggregate data set for further refinement. So with that, I'd like to leave everyone with a few resource links to help get you started, or simply remind you where you can go for more information on the Snow family of services. If you have not ordered a Snowball device before, I strongly encourage you to do so and or reach out to your account team for a demonstration.